The question was, if I take a 200 gram mass and I let it stretch that spring, and then I take another 200 gram mass and I put it on two springs, spring, connected in a series, was stretch more than 25 centimeters, the same, or less? Let's do it. And these are supposed to be identical springs, but they're not actually. Now let's go ahead and measure this. So it's stretched down here. From right there, I'm going to take it off. It's hard to see. It definitely is farther than that. So I get 49 centimeters, which is very, 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 very close to twice of 25. And that's the answer. It should stretch twice as far with two identical springs. Why? Okay, a lot of people think, well, it's the same spring, right? Okay, let's fix this point right here. I have two springs in series. Fix this point. I put a mass on there, and this is going to stretch. It's the same as sticking this to the wall. That's going to stretch 25 centimeters. Now, if I take this point right here, looking at that spring, and assuming massless springs, no mass springs, then what force is pulling down that spring? What's all of this stuff, which is 200 grams. It's going to make that one stretch. So that's going to be 25 centimeters. That's going to be 25 centimeters. Total 50 centimeters. So two springs in parallel would make, series, it's series, would make it stretch twice as far. Now, here's your homework, and I'm not going to answer this question, okay? If I use this for my model for the spring force, the spring constant K times the stretch X, which really should be something other than X, but that's fine. If this has a spring constant of K, what's the effective spring constant of two springs in series? What's the effective spring constant? So if you treat it as just one spring, how would its spring constant be? I will answer this question in the next video, and I just lied. I said I was going to do 2 videos, but it's going to be three videos.